Today, let's look at this interesting problem regarding infinite product. Here is a question. Let P be the set comprising all prime numbers. Find the value of the product of 1 minus 1 over P squared, where P are elements in P. So the first few terms of this expression is 1 minus 1 over 2 squared times 1 minus 1 over 3 squared times 1 minus 1 over 5 squared times 1 minus 1 over 7 squared, and so on. Please have a good try before you look at the answer. We will present two different methods to solve this problem. Method number 1, let's recall the geometric series. 1 plus x squared plus x power 3 and so on, and in general x power n. This series is called a geometric series with first term 1 and the common ratio x, and is equals 1 over 1 minus x provided that the modulus of x less than 1. So if x equals to 1 over 2 squared, then we sub in x as 1 over 2 squared, we obtain 1 plus 1 over 2 squared plus 1 over 2 squared plus 1 over 2 squared power 3, and so on. And using the formula, we will have it is 1 over 1 minus half square. If x equals to 1 over 3 square, we will have the following, and the sum equals 1 over 1 minus 1 over 3 square. Let us look at this series again. We know that 1 over 1 minus half square equals 1 plus 1 over 2 square plus 1 over 4 square plus 1 over 8 square, and so on, and in general it is 1 over 2 to the power n square. Whereas for the other series is equals to 1 plus 1 over 3 square plus 1 over 9 square plus 1 over 27 square, and in general is 1 over 3 to the power n square. So if you take the product of these two series, we'll obtain the first term 1 and the second term 1 over 2 square, and it followed by 1 over 3 square, 1 over 4 square, 1 over 6 square, 1 over 8 square, 1 over 9 square, and so on. The general term is 1 over k square, where prime factorization of k consists of the primes 2 and 3. Let's extend this result and consider 1 over 1 minus half square, 1 minus 1/3 square, and 1 minus 1/5 square. From the previous argument, we know that these will equal to the summation of 1 over k square for all k in the form of 2 to the power m1 times 3 to the power m2 times 5 to the m3. Therefore, in general, the product of 1 minus p square over all prime p will equal to summation 1 over k square from k equals 1 to infinity. As you know from the previous video, that this expression equals pi square over 6. And therefore we conclude that the product of 1 minus 1 over p square over all prime p equals 6 over pi square. And this end of the method 1. For method 2, we use the result that we obtained from last video, that is pi square over 6 equals to 1 over 1 square plus 1 over 2 square plus 1 over 3 square, and so on. Now we will multiply each term from the left hand side and the right hand side by 1 over 2 square. So from the left hand side, 1 over 2 square times pi square over 6. And from the right hand side, 1 over 2 square plus 1 over 4 square plus 1 over 6 square, and so on. Denote these two equations as equation 1 and equation 2. Now consider equation 1 minus equation 2. 1 minus 1 over 2 square times pi square over 6 will equal 1 over 1 square plus 1 over 3 square plus 1 over 5 square, and so on. Note that from the left hand side, 1 minus 1 over 2 square is equal to 3 over 4. And 3 over 4 times pi square over 6 equals to pi square over 8. With this, we obtain an interesting result, that is summation of 1 over 2k minus 1 square, where k equals to 1 to infinity, equals to pi square over 8. Let's go back to the method 2. Using the similar argument from what we have just now, we multiply both sides by 1 over 3 square. And from the left hand side, we have 1 over 3 square times 1 over 2 square times pi square over 6. And from the right hand side, we have 1 over 3 square plus 1 over 9 square, and so on. We call these two equations as equation 3 and equation 4. So equation 3 minus equation 4, 1 minus 1 over 3 square times 1 minus 1 over 2 square times pi square over 6. And on the right hand side, 1 over 1 square plus 1 over 5 square plus 1 over 7 square plus 1 over 11 square, and so on. And we can proceed this, and we will see that the next step will be 1 minus 1 over 5 square times 1 minus 1 over 3 square times 1 minus 1 over 2 square times pi square over 6 equals to as such. Namely, the terms exclude those terms in 1 over k square, with k consists of prime factors 2, 3, or 5. And we can proceed this to as many as 1 minus 1 over p square as we want, and until all the prime numbers. So on the left hand side, we have the product of 1 minus 1 over p square over all prime numbers times pi square over 6. And on the right hand side, we have only 1. And therefore, the product that we want is equal to 6 over pi square. The presenter identity reveals an intriguing fact. When two natural numbers are randomly selected, the probability that they are regularly prime is 6 over pi square, which is approximately 0.61. Hope that you learned something new today and enjoyed this video. That's all for today's discussion. I'll see you again next time. Bye-bye.